In the Siemens portfolio, the IonPure name is known as a leading provider of innovative products for system integrators worldwide, such as continuous electro-deionization, or CEDI, for chemical-free production of deionized water. Siemens' patented IonPure CEDI technology removes ions from water using a unique combination of ion exchange membranes, ion exchange resins, and electricity. The ion exchange resins are continuously regenerated, without the need for regeneration chemicals. To understand how the patented IonPure CEDI technology actually works, let's go down to the molecular level and take a look at some water containing ions. Water contains positively charged cations, represented by plus signs, and negatively charged anions, represented by minus signs. When a pair of electrodes is inserted and an electrical current applied, the electric field drives the cations in the direction of the cathode, and at the same time drives the anions in the opposite direction, toward the anode. When we insert an ion exchange membrane made of cation selective resins, it will block the flow of anions and water molecules. Only cations will be able to pass through to the other side. When we insert another ion exchange membrane, this time made out of anion selective resins, it will block the flow of cations and water molecules. Only anions will be able to pass through to the other side. This configuration of membranes and electrodes forms the framework of a CEDI module. This process is limited, however, by the slow speed at which ions move through water. In effect, the low conductivity of water impedes ion removal. In other words, as the product compartment water becomes more and more pure, the electrical resistance of this water increases and counters the effect of the electrical field. IonPure CEDI technology solves this problem by sandwiching a mixture of cation and anion selective resins between the two membranes. The large surface area now offered by the resin beads effectively eliminates the ion diffusion resistance and allows the ions to move freely, even in ultra-pure water solution. The surface of the resin beads acts as a conductive path, effectively acting as a bridge for the ions to move quicker toward the membrane surface, faster than if they were in water alone. Taking a step back to look at how an IonPure CEDI module is constructed, we can see that if we move the electrodes farther apart and continue to add resin beads sandwiched between the cation and anion selective membranes, we create a series of water purification compartments, alternating with compartments where the ions are concentrated. As feed water is pumped into the system, it is diverted into separate compartments, mainly the concentrating compartment and the purification or dilute compartment. These water streams remain separated throughout the process because only ions can pass through the membranes. Ions migrate and accumulate in the concentrating compartments, where they are washed away into the reject stream. The water leaving this compartment contains a concentration of ions approximately 10 to 20 times higher than the original feed water. This water may be drained, recycled, or reclaimed for further treatment. At the top of the purification compartments, the ion concentration is at its highest. Here, the surface of the resin beads acts as a conductive path, effectively moving the ions to the membrane. At the lower end of the purification compartments, where the ion concentration has been reduced to the parts per trillion level, the electric field becomes concentrated between the resin beads and the surrounding water. When this localized voltage potential exceeds approximately 0.8 of a volt, an electrochemical reaction occurs, and water molecules are split into hydrogen and hydroxide ions, which are essentially acid and caustic. The acid and caustic generated in the module regenerate the resin beads by replacing other trace ions remaining. The attachment of hydrogen and hydroxide ions to the resin beads is exactly what happens to resin beads when acid and caustic are used for regeneration in conventional deionization systems. As a result, IonPure CEDI systems do not need chemicals for regeneration. The electric potential does all the work. You essentially have a worker and polisher combined into one unit, which constantly regenerates. And ion-pure CEDI systems are more effective than other electrodeionization systems when it comes to removing dissolved materials such as salts, acids, and bases, as well as weakly ionized materials such as dissolved organics, silica, boron, and carbon dioxide. This continuous regeneration process also eliminates pH shock and greatly extends the life of the resins. Through the IonPure name, Siemens continues to innovate and offer state-of-the-art water technologies to OEMs worldwide.